Good morning and welcome back to Hack the Machine. How are you doing this morning, Nicole?
I am great. I'm so excited to find out what's happened overnight.
I know a lot happened. Hey, everybody, we've got a great show lined up for you today. I want to share a couple of changes that are on the set this morning. You'll see behind me 2 growth programmers at the Grace Maritime Cyber Console. If you want to get an up-close look at what some of this technology looks like, this is actually live streaming on YouTube for the duration of the day. As soon as we come off the track update segment of the program, say something in track 1 Slack. The mentors will give you that link there for YouTube, and you can get an up-close look at some of the equipment. Nicole, let's get people caught up on what happened yesterday.
All right, so if you're just joining us, we launched yesterday with leaders from the Naval Sea Systems Command, Naval Information Warfare Systems Command, as well as the Chief Officer of Naval Research. And we kicked off all 3 of our tracks for maritime cybersecurity, data science, and heavy metal.
Awesome. I can't wait to get going with the rest of it. But before we do, let's get kicked off with Admiral Selby as the Chief of Naval Research again. I think, Admiral, we've got you on the line this morning. Just want to check in. How are you doing?
Good.
I think we got your audio on, sir?
I hope so. I'm talking.
All right, good. Admiral, you know, you've helped me launch the competition yesterday. We had a bunch of things happen. Some new ideas even came on yesterday. What are you excited about this morning?
Well, I'm excited to hear what happened overnight, and I want to see if anybody was able to catch one of those 3D printers on fire like last time.
No, you know, we've got a game that we're running backstage to actually protect printing enclaves. We'll be doing an update on that, I think, tomorrow. So we'll show you what we've learned since then. I wanted to talk about this outreach piece because, you know, Hack the Machine is such an important part of some of the outreach that you're doing. We're here at NavalX in Alexandria, and you're the resource sponsor for this organization. So first off, thank you for making that sort of outreach possible. But the program is really a lot broader than this one location. So I was hoping you could tell us a little bit about the nationwide Tech Bridge ecosystem and how that helps the Navy connect to innovators and tech hubs all over the country after the event.
Yeah, absolutely. So NavalX, and then by extension, their tech bridges are like nodes in a network. And they are kind of out in different corners of the United States, as well as now one in London. We have a tech bridge in London now. And they're there to try to establish relationships with academics, small businesses, other government organizations sometimes, and really having a conversation about what are some of the challenges we see in the Navy and Marine Corps that we need help with, and what are some of the things that some small business somewhere that doesn't traditionally deal with maybe the Navy or the Marine Corps, how do they work with us? And so the tech bridges are out there trying to establish those relationships in those outposts, those nodes, trying to establish those relationships to try to, you know, marry someone with a solution with someone with a problem, bring them together, be a connector. And this Hack the Machine event is yet another kind of amazing event that brings in a lot of folks that we don't traditionally see and exposes them to some of our, I think, really unique, and I think really cool and interesting problem sets that we're trying to deal with. And they come to us with all kinds of new and different and oftentimes better ideas than we would have come up with on our own.
So that's fascinating. So I want to make sure I understand this. So if we have somebody who's participating in Hack the Machine, having a great time, and then, you know, has played the game, scored some points, maybe they even won some money, they could actually learn more about the Navy. So they could go to, Google NavalX and find a tech bridge close to them and actually either contact them, come in, and just start to learn how to do business with the Navy and about some other real problems we're having that we're actually looking for innovators for, right?
Yeah, absolutely. They can get in. And again, we put these in places where it's easy to get into. So usually outside the gate, outside the wire, as it were. So you don't have to have a CAT card or government credentials. So absolutely.
Yeah, we're right down here in the middle of downtown Alexandria. So that's easy. And by the way, the city of Alexandria, sir, I don't know if I told you about this, has been amazing. We're going to, on Friday, when you're back here to help me give the awards out, we're going to run through some of the ways the city has been amazing. It's been a collaboration, exactly the kind we're looking for. I had one other question about collaboration for you this morning, sir. COVID-19 has made it difficult for teams to come together and do things like this, but it's also forced us to try new ways of collaboration. And I was hoping you might share some lessons learned about the way we've had to collaborate during COVID that you think will be important about continuing into the future.
Yeah, well, I think all of us have experienced obviously COVID is impacting everybody across the globe. And It's just the fact that I'm sitting here, on a Skype event with you, coming to you from this beautiful underwater realm that you.
Yeah, you're a submariner. You had to make a background to be underwater, didn't you?
I had to. But I mean, this has taught us that hey, there are different ways of doing business, and in fact, while I miss the personal connection, I think that's still something that's important. You can now scale your outreach with these kind of venues. You can now reach thousands where before you might have only gotten tens or hundreds. And so I think there's going to be a balance as we come out of COVID of trying to strike how much in person, how much virtual. So I do believe that the outreach we're achieving at Hack the Machine event like this one, or a lot of the other events I speak at now when I do them on Teams or Skype or some other Zoom or whatever it is, I am now actually reaching thousands, where before it was maybe single digit hundreds, 100 or 200, something like that. So that aspect I think is important because again, the problems we have today are highly complex, and we need all of the brightest minds we can gather together to help us solve those. And you can't always get them in the same physical location. And so using these virtual means, I think, is a way to actually improve the outreach, improve the connectivity, and hopefully improve the problem solving and the innovation that will come out of that. So I think there's some things that are coming out of COVID that are actually, I think, will sustain and will provide better connectivity and some goodness going forward.
All right, sir. Well, we appreciate that. We certainly hope to see that sort of collaboration with the tech bridges all over the country. And to your point, we just crossed 1,000 people registered for Hack the Machine today. So we're into the thousands, and yeah, you nailed it. Thanks for helping us kick off. We'll see you back here for a quick virtual check-in tomorrow morning, and then you'll be back with me on Friday to give away awards, right?
And I'll wait. Yep, so see you again tomorrow, and looking forward to Friday.
All right, sir. I really appreciate it. Nicole, I'm going to run off and check some things backstage.
Okay.
We're actually going to get look at some things going on, and so I'll see you in a minute.
Awesome.
All right, be right back.
See you later, Zach. All right. Well, as we learned yesterday, NAVC is one of our key sponsors for Hack the Machine. Yesterday, we met NAVC leaders Rear Admiral Lloyd, the Navy's chief engineer, and Rear Admiral Okano, the program executive officer for integrated weapon systems. Today, we're joined by Rear Admiral Wynn, who is leading a new organization that brings together cyber and digital expertise under a single leader. Welcome, Admiral Wynn.
Hey, thank you, Nicole. Glad to be here.
I'm so glad that you came over to visit us in this lovely space.
Yeah, I'm a long-time fan, first-time visitor.
Well, we're always glad to have fans. Yeah. So, NAVC recently reorganized and brought together shipboard cybersecurity under your leadership with traditional enterprise cybersecurity. Can you tell us a little about the synergy that is going on to allow you to achieve this?
Yeah, so the establishment of the NAVC Cyber Engineering and Digital Transformation Directorates create a single line of authority and accountability for cyber and digital effort under my command at CO3. This new organization construct consolidates technical abilities, knowledge and experience of anti-related cyber and digital capabilities, technology governance for better integration of both afloat and ashore systems. NAVC focus has always been on continuous improvement of cyber defense with new capability, new innovation to detect, protect, and recover from cyber attacks. I believe that whether it is IT or OT, there are common technology and governance in the cyber area that can be beneficial for both. Example of this is the use of the cyber awareness tool that we developed under the ashore systems that we are now considering to use it for the float systems.
Oh, that sounds amazing. Yeah. So it sounds like you guys are making tons of progress already, and you've only been around a year. That's great.
It's been a long year, but we are trying to make some progress. Yeah.
Well, okay, so on the commercial side, we've got the International Maritime Organization, and there are other organizations that are just starting to focus on the industry on maritime cybersecurity. Right. Do you see this as like an open problem, and are you interested in innovators and entrepreneurs helping the Navy solve this challenge?
Oh, absolutely. The Navy operates in the model that relies on partnership with industries and international partners. There are many technology common to commercial ships and Navy ships, particularly in the HME area, the whole mechanical and electrical system. The focus on maritime cybersecurity is important because it will bring people, innovation, ideas, and technology that will play a key role for our Navy. One of the fun things about Hack the Machine is that it is open to the public, which allows us to build an informal community of practice with our cyber practitioners and other like-minded colleagues all over the world. We are happy to have competitors from our allied navies in Australia and others participating this week, and we look forward to our community continue to grow over time.
That is great. And you're right, we do have people competing from all over the world, so that makes this such a broader reach, right? Hack the Machine is a lot broader, of course, as well, than maritime cybersecurity.
Right.
And I'm personally connected to the second part, so you're doing data science, right? And we're following that in track 2. And we have advanced manufacturing in track 3, which you also care about.
Right.
And then if you think about your role, part of your job is oversight of all of the digital transformation for NAVC.
Right.
So can you share some thoughts about why this more holistic perspective is really important to you and some of your objectives along the journey?
Great, yeah, thank you. What digital transformation brings to the Navy and to NAVC is the ability to bring capability to the fleet faster than traditional business or software development processes in order to stay ahead of our adversaries. The idea of compile to combat in short order can be realized without process such as the DevSecOps process. And really, when it comes down to it all, it is all about the data. Data is the new currency that allows us to develop AI, machine learning, expert systems, so on and so forth. One could say that the lifeblood to AI is really about the data itself, because without the accurate data, it would be meaningless. Other digital capabilities such as additive manufacturing is also key technology to maintain and overhaul ship faster to keep our ship and submarine at sea. So collectively, these transformation technology are the bedrock of our digital transformation. An event like this create the synergy between different disciplines to help us this holistically about transformation that we have it underway.
Well, you know, I think it's amazing because you think about the data, all of the technologies, and the people, right? You've got to change the people to do all of these things.
Yeah.
And Hack the Machine is the microcosm of all of that.
Right.
So I really do thank you so much for joining us today, sir. And we look forward to presenting you with all of the things we discover this week.
Oh, I'm looking forward to, again, I'm very excited about being here. So thank you for inviting me to be here today.
I cannot thank you enough for joining us. Thank you.
Thank you.
Awesome. So now we have learned exciting things that are going on at NAVC and big visions that Admiral Wynn has for that organization. So let's give everybody, you know, an update on what we've actually had. We had an update on track 1. Sorry. What did they do yesterday? I'm so excited about what NAVC's doing.
No, it's a lot, right?
I got
So
wrapped up.
Yeah.
All right. So let's find out what's going on with track 1 there.
Oh yeah, absolutely. You know, and having Admiral Wynn on is so refreshing, right? I mean, it was fun to open up with Admiral Lloyd yesterday, who really had some impact on all 3 of these. But we see that it's so interwoven with Admiral Wynn and CO3. Again, has data and cybersecurity and security around how the additive manufacturing process will work on board ships. So it's really a holistic, integrated whole, like he was talking about.
Absolutely.
Yeah. Well, let's talk about track 1, though. Let's get started with the track updates. It was a really busy day yesterday. We had teams forming up and getting started in all of the tracks, but in track 1 in particular, we provided the data for our contestants to start offline challenges so they can score points. And through those points, they qualified to attack some of the systems you see on stage here behind me. Good morning.
Good morning.
I'm joined by Dr. Dave Burke, our track 1 lead. Dave, catch us up, man. What's been going on in track 1?
Oh, it's been exciting. We've opened both the Grace Maritime Testbed as well as the Crash Game to online contestants across the world. It's very exciting. It's been an exciting first day. We've had 218 participants in the track 1 Capture the Flag game organized into 48 teams. All the teams have received their offline challenge at 1 p.m. Eastern time yesterday, and we've been working to qualify on the online challenges that began this morning. So let's show the leaderboard. Currently, we have Terminal Cats leading the pack with 1,611 points. We have Surcouf at 1,396 points, and SDR Ship Troopers at 1,196. The teams are earning points on the Cyber Maritime Testbed by doing an analysis of pre-recorded NMEA 2000 packet capture data from this Grace testbed. So that all the points that you're seeing here are from the offline challenge associated with Grace. After demonstrating they've earned 1,200 points, they have qualified to go live on this on the laptop that we have here on the system. So we have now 2 teams that have fully qualified to go live onto the the OT portion of this. NMEA 2000 is a maritime-specific message protocol that runs on top of CAN bus and the OT network that most people have in your car. Qualified teams will have 1 hour and 15 minutes each to cause effects on the Grace testbed. This could be effects such as taking control of the throttle system or spoofing navigational data. This is similar to what the Grace Aviation cyber testbed experienced in another section of the building where the Navy red teamers are hacking away. We'll take you to them later in this broadcast. Teams are also earning points today on the crash game. Here is the crash running on these servers with a bunch of vulnerable virtual machines, aka VMs. The qualifying round for crash is ongoing, and teams are demonstrating that they can exploit these vulnerable VMs. We've recorded one of these hacks to show you what it looks like inside the system. So what we have here is a hacker attacking the elk stack system. There's 3 different exploits we'll show here. Thankfully, this hacker is actually pretty quick. So if anybody actually wants to know what attacks look like, this is what they are. We've tried to add a little bit of examples to it so that you can see what's going on. We've also blanked it out so that nobody on the other teams that's watching gets an unfair advantage. Can't give away the answers here. So this is attacking the elk stack system. We're listening on netcack. And there you go. 1 full machine has been compromised, and they have root access to the system. So now the attacker here is jumping over and attacking a different one. This is going to be the Nginx virtual machine. And you got to love the hackers with their ASCII art. So we have the bomb there. And in just a moment, you'll see again that this is a successful exploit. Oh, this hacker decided, yep, here we go. And it's completed. And the third one here is an attack against Snort. So these are the 3 applications that are running inside of the crash game. This is an example of the systems that are unprotected. So the goal for crash, they'll be attacking the unprotected systems today. And then we'll be turning on the protections and allowing them to actually attack against those items.
Dave. So you've actually already got people who've successfully attacked some of the VMs. That was competitor demonstrations, right?
Yes.
That's amazing. You've got people who've scored points in the offline challenge and crash?
Yes.
Oh, that's great. And we've got people signing up for those top competitors are actually able to get live on the system and start scoring points as well.
Later today, they'll be live on the test bed.
And so we should be able to potentially demonstrate some of the maritime attacks for people on the test bed tomorrow, like you demonstrated some of the command line attacks today?
Yeah, I'm hoping we can show them attacking the whole system and affecting probably the navigation data.
Oh, that's awesome, dude. Well, dude, you've won a round of Lead the Stage.
All right,
We'll see you. Take care. Yeah, so I'm really looking forward to see how the live updates are going to go. You know, we had that offline piece, but just today, people will start getting on the system. They'll have an opportunity in those live attack positions to go after both Crash and Grace. And a little bit later in the program, we're going to show you how those insights are already making a positive impact on maritime cybersecurity. But I'm rejoined on the stage by Nicole. And it's time for your favorite part. We get to talk about data science.
I gotta tell you, I'm excited about track 2. That's gonna be cool too, though.
It is.
All right, so I can't wait to talk about track 2. I think Zach's gonna go check some things out in the studio. So I'm gonna have Monica London from Fathom 5 join me to tell me what's going on with track 2.
Good morning, Nicole. Thanks for having me.
Great. I'm so glad you're here. Tell us what's happening on track 2.
So we've had 73 participants making up 18 teams submitting results for the first day of the competition. There are 3 challenges in track 2 this year, and we won't be able to grade 2 of them until Thursday, but we're already seeing points on the leaderboard for the 3rd challenge. We had 3 teams with over 1,800 points. AlgoBot is in the lead with 1,882, followed by It Must Be in the Data and KDS Lab. Also, the bottom 4 on the leaderboard are tied with 1,740. This is what makes competitions like this so exciting. It will be interesting to see how the leaderboard looks tomorrow. Part of my team has been directly interacting with the contestants, and we have a few interesting stories from the first day. Let's go to Jason Tickey and the team from NVIDIA to share some insights. Good morning, Jason, Ryan, and David. You have been interacting with our contestants as they got started on the problem yesterday, and we look forward to hearing what's going on with the teams.
Thank you, Monica, and thank you for Teams for inviting us on your Slack channels. It is great to interact with you. We are data scientists from NVIDIA. We have, great people like Ryan and David. David being an expert in NLP as a great resource for everybody, and it was great to see everybody attack the challenges. I think the first thing I noticed, and rightfully so, was I think every team out of the gate went after Challenge 3. But there were results due at the end of the day, so that made sense. So I'm actually looking really forward today to seeing teams tackle Challenge 1 and 2. My coworker Ryan and David and myself yesterday even cracked open the data and thought about how we would attack it ourselves. And so I'll let Ryan talk about some of the things he's tried, and talk about, Ryan and David can talk about what they've seen the teams try.
Yeah, thanks, Jason. So I personally took a quick look at challenge number 1 and did some exploration, and I think it's very representative of, some of the things we see in the real world, where you might not always have as much data as you would hope for. It might not always be in perfect condition. So I think they've done a pretty good job of representing real world situations there. I have had some tests going with running either LSTM models or some other kind of workflows, just see what I could get going. So it'll be really interesting to see what some of the teams start coming up with today. And I could turn it over to David, who's actually our natural language processing expert out of our group. So, David?
Yeah, thanks, Ryan, and good job on your work yesterday with the LSTM. So, the teams aren't disclosing so much about what each one's working on, and I can understand that out of the spirit of competition, but we did get a few clues about the way that people are working. One of the ways that we see is that people might be applying techniques like BERT. BERT is a technique for natural language processing that can examine a sentence in 2 directions, both forwards and backwards, to look at relationships between the words or pairs of words, n-grams in a sentence. That might actually have been an approach that I tried. Ryan, I wasn't able to sit down and try something like you were, but I thought about ways to parse apart those sentences that were part of the scenarios in Challenge 1. I might have actually thought about approaches that are using named entity recognition to pull things like ages, places, or conditions about mask wearing out of those to try to compute a score for how dangerous the scenario might be. I also considered the notion of using question answering, where if we were to use natural language understanding to query one of the scenarios to see if people are wearing a mask, to see if people are distanced, and then adding those into a danger score might have been an interesting approach. But I think what's going to be most interesting of all is to see what people are actually doing in the challenge. We didn't see too much chatter in the Slack about the second challenge then, involving summaries and how to pull together a specific case with general guidance. I don't think that we saw too much with that, but with the third example, the third challenge, it seems like people are starting to take a linear programming approach to that. So that's what I've got so far. I'm really interested to see what the teams are doing. It's really great to be interacting with as many as we are.
Yeah,
I'm
David,
also really, yep, go ahead.
I was just going to say, I think it really speaks to the iterative process of, the trial and experimentation that goes on with this. So it's definitely, where something might not work that great. I wasn't seeing that great of results initially with the LSTM. So I've actually already started going down that similar track as you were. So it would be really exciting to see what some of the people come up with. So
Ryan's also feeling some of the pain of trying to train from scratch. This is a minimal amount of data, and especially for Challenge 1, it's very wordy. So one of the challenges is, do you try to train a neural network from scratch, or use something like transfer learning, where you can take an already learned network and try to use that to apply it to a small amount of data? I'm really excited to see what the teams themselves come up with for both Challenge 1 and Challenge 2. I also agree. I saw a lot of linear programming models for Challenge 3, and I think most of the competition in Challenge 3 is going to be writing your cost function and trying to be clever with conserving your resources for multiple days. But I do agree with the linear programming holistic approach. I mean, I think that's how hospitals today schedule their resources. So I'm interested to see some of the great ideas out of all the 3 challenges. Monica,
sorry, back to Monica.
Thank you, guys. There really is a lot going on. As things progress, we'll be reaching back out to you all for more updates.
So what's fascinating about all of that, Monica, is the fact that the problems that they're finding in the data are the exact same problems the Navy has with their data natively right now. And that has been so amazing to hear them talk about and having you present. Now, I know you're itching to get back to monitoring the game, so I'll let you go back to work. Hopefully, we'll see you tomorrow and you can give us more updates.
Thanks, Nicole. I'll see you tomorrow.
Great. Now, it looks like things are shaping up really well for track 1 and track 2. Where's Zach? I want to know what's going on with track 3.
Hey, yeah, so we are, like I said, getting something ready off stage. We'll be out there in a minute. But you're right. Let's get the update from track 3, and then we're going to go check out some stuff behind the scenes here at NavalX. You know, track 3 is so important to the Navy's digital capabilities because the design and engineering processes that we heard from Admiral Lee yesterday are moving toward a digital production model, whether that be model-based systems engineering or advanced manufacturing on the digital thread. So Matthew and Samantha are going to be here with us to tell us today about how all that work got started. So, hey, good morning, guys. How are you?
Good. How are you?
I'm doing excited. We keep bringing you up third, even though I think some of what you guys are doing is most important. So maybe, I don't know, maybe we'll switch it up, maybe we won't. But please tell us, yeah, how's it going? What's up?
Well, as you may have seen yesterday on Slack, track 3 is super busy. After launching the challenges, we had the honor of meeting now over 500 participants. Submissions are rolling in for the scavenger hunt, so be sure to lock in your responses now before somebody else wins.
Yeah, and somebody is going to win a $5,000 prize on our Challenge Coin competition. Keep an eye on Slack and the Challenge Coin Slack channel and vote on your favorite. The sooner you get your Challenge Coins submitted, the more opportunity you'll have to rack up votes. Remember, it ends at noon Eastern tomorrow.
So while our scavenger hunters are hunting and our challenge coin designers are designing, our main event is underway. The teams are warming up their printers as they interpret 2D drawings to make sure their fully functioning 3D prints are ready to be inspected, as well as vibration and shock tested. Now, while the traditional manufacturing process for a part like this typically takes months to years, Hack the Machine participants will compress the part production into just 2.5 weeks. The digital engineering practices and digital transformation goals of Admiral Selby and Admiral Wynn make this aggressive timeline possible.
Some of the most common questions we've been receiving include anecdotes about how do we use the Turbo TDP software, so we're guiding folks through that process. And on the additive manufacturing side, what kind of materials can we make this part out of? What kind of processes can we use?
Matthew, that's a great point. I've also been fielding questions about what the lighted up participants are actually doing right now in their labs, offices, and factories.
Yeah, we expect the contestants for the main event are going through this design phase where they're taking the 2D drawings that we supplied them yesterday and making 3D CAD models out of it. And then they're going to optimize that process and look at simulating the product, selecting the materials, the printing processes, determining optimal post-processing settings. And this is all very technical. 3D printing is complex, but metal 3D printing takes it to a whole new level.
Matthew, you mentioned post-processing. What exactly is that?
For metal additive manufacturing, post-processing can take a couple of different forms. Maybe they're just smoothing the surface on the outside of the part through some post-processing that will give the part more integrity. It could be a process where you take the part out of the printer, put it into an oven in order to sinter the product to make it stronger, or even using hot isostatic pressing.
Now, we expect that participants will be iterating multiple times on their printed piece and refining the products over the next 2 weeks. In addition to producing a functional metal part, participants are assembling a robust technical data package, that's a TDP for short, as well as a video diary to capture the data, process, and quality of their work. Now, this challenge is truly a test of capability and experience, and we cannot wait to test their hard work in just 2 weeks.
Samantha and Matthew, thank you both so much for being here. That sounds so exciting, and I can't see what gets produced. I can't wait to see what gets produced. But like Monica, I know that you need to get back to monitoring the games. So I thank you so much for joining us today, and I look forward to seeing you tomorrow so that we can learn some more about what's happening on track 3.
Thanks so much. And don't forget to submit your challenge coin by noon Eastern tomorrow.
Excellent.
Good to know. So, speaking of testing capabilities, earlier I passed by a red team that was working on something I've never seen before. And I think that's where Zach went.
Let's go. We've only got the seconds here.
Oh, okay, Zach's still getting set up. Hopefully he's going to tell me what's happening on that red team. I unfortunately don't know a lot about what they're doing back there. Zach is our technical expert, and he can always keep me up to date and informed as we move along. If you haven't caught on so far, everything that we're seeing out of all of the 3 tracks, however, is directly relevant to the things that we're doing in the Navy. So, we're ready for Zach.
All right. Well, hey, like we said, there's a lot going on behind the scenes, and I wanted the opportunity to show a little bit more of what's at NavalX and some of the things that are going on here. On the main stage, we've got the Grace testbed and crash, so we're doing both maritime and IT security, but the Navy is ships, submarines, aircraft carriers, but it's also fighters, helicopters, and unmanned aerial vehicles. And like we talked about yesterday with our NavAir sponsor, it's just as important that we start figuring out how to identify and mitigate cyber vulnerabilities there too. So this is a brand new aviation cyber test bed. Brent Redmond built it. He's been running the game here. Brent, tell us a little bit about what this is.
Yeah, so much in the same way that we've seen a lot of maritime systems that run off of serial protocols such as CAN bus or NMEA 2000, avionics equipment also have their own form of serial communication. Okay. In this case, it's called ARINC 429. And so that's one of the key functionalities that Aviation Grace right here behind me provides, is that it gives the user complete and total control over a live ARINC 429 serial bus.
So we've got Anthony flying here, but this is a flight simulator. I think everybody's been around the Navy for a little while or has seen a flight simulator, but we've got this is like a cyber engineer's workstation next to it. So what can you do from the cyber workstation that makes this not just a flight simulator?
Right, so there's 2 key things that we can do. On one hand, we can read and write messages to the serial bus, and we can get physical access to those messages by accessing the patch panel over on the right-hand side. Or we can also write messages to the bus, and we can see cyber effects take place in a simulated environment on the simulator right here.
In real time. So when I leave, you're going to start messing with Anthony?
Yeah.
All right. I think that's awesome, man. Thank you guys for what you're doing. The intent is that we're going to bring a game like this so people can try and beat your high score at the next game, right?
That's right.
All right, man. Thank you. Awesome. Hey, let's go check something out. So that's a little bit about the future of where we're going with expanding the style of gameplay we're running at Hack the Machine. What I also want to do now is talk a little bit about how your insights are feeding defenses. So it's fun to do the hacking thing, but what really matters is kind of raising the level for everybody on protection. You'll see a lot of the equipment in this downrange set that you saw out on the main stage on the Grace test bed. I want everybody who's played Hack the Machine with us for a few years to know that things that you showed us that are possible in maritime cybersecurity help make NAVC decisions about things we needed to protect against. This system has actually been out to sea twice. It's a target that allows us to test the things that we did in the lab. Do they actually work at sea? And then for the things that did, Naval Surface Warfare Center Carter-Rock, the Combatant Craft Division there, recently ran an experiment in conjunction with Admiral Wynn's team, who you met earlier, to take 4 technologies that looked promising on paper. We took them out to sea so we could see if things we can do in the lab can be prevented at sea, so that there's this really nice, tight, fast circle of less than a year between when we learned something is possible, we found something that claims to protect it, and then we actually did the at-sea test. One last thing I want to show you here at NavalX is related to what's going on in Track 3. We're going to follow me in here for just a minute. And we've got this bank of 3D printers. We know Track 3 is about metal 3D printing. Metal 3D printing is just absolutely vital to the Navy's ability to print parts out of metal. But for most people that have printers like these that are hobbyist level 3D printers, metal printing is just kind of out of reach. Not anymore, and we're really excited about this. So if you're out there and you're wondering how you can print in metal on your own hobbyist printer, tune in today at 2 p.m. Eastern when our community partner, Matter Hackers, is going to be sharing about some information about a new filament that allows you to print in stainless steel. Now, Matthew just talked about post-processing for 3D printing. There's, of course, some post-processing that needs to happen to take that stainless steel filament and actually get to your metal part. But it's possible now. It opens up a whole level of creativity for people with printers like this. And we're really excited to share it with you later today at 2 p.m. Nicole, back to you.
Thank you so much, Zach. Well, this ends our track updates for today. And up next, we have our community partners directly relevant to all 3 of our tracks. First up is FireEye at noon Eastern, sharing their insights about industrial control system vulnerabilities. At 12:20, next we will have our community partner segment of Georgia Tech Research Institute. GTRI is a university-affiliated research center, or UARC, and they will be discussing how UARC support the Navy's cybersecurity technology development. Joining us at 1 p.m., there's Booz Allen Hamilton, where they will lead a panel of data scientists from the Naval Information Warfare Center on Navy data science workforce development. At 2 p.m. Eastern, we'll have our community partners in Track 3, Matter Hackers. This is a discussion Zach was just referring to, so you can learn how to print in metal on your polymer printer. We'll then have our community partner, Mara, from, oh my goodness, I just forgot her name. We have another one. It's gonna be a surprise. And so we'll take a short break and we'll join with our community partner sessions back at noon. Be sure to check out the agenda on HackTheMachine AI/agenda to find out about all the sessions and make sure you don't miss a link. Don't rely just on me. Also, don't forget to join us back here tomorrow at 11 a.m. Eastern, where we will get our track updates as challenges really start to heat up. They're already exciting. Bye, guys. The threat to the U.S. Navy and its allies and partners from cyber intrusion is constant. And hackers, particularly foreign adversaries, are not limiting themselves to attacks on traditional computers and networks. During this session, FireEye's Sam September sits down with Mandiant government intelligence strategist Jason Atwell to talk about real-world threat scenarios, operating with allies when it comes to foreign adversaries, managing fleet technology systems in an expeditionary environment, and how to identify supply chain cyber threats and technical and operational countermeasures to mitigate those threats. Welcome. Welcome, team from FireEye. How are you?
Good. How are you? Thanks for having us.
Great. I'm glad to have you today. All right. I'm looking forward to hearing what you've got to tell us today that I've never heard of at FireEye. Oh, yeah, the floor is all yours. Sam and Jason, whenever you're ready.
Thanks. Sam, I can't hear you if you're talking.
All right, we are trying to make sure that we can get Sam and Jason to both hear us so that you can hear.
I don't know if you can hear me. I think I'm having some pretty bad audio.
Yeah, I can hear you now,
today.
Sam.
Thank you, everybody, and welcome. I'm Sam September from FireEye. I'm Strategic Alliances and a Mandiant consultant here for the Department of Defense. I want to turn it over to Jason, who is our Senior Intel Strategist and Advisor, to talk about a little bit about the Navy's efforts around JADC2 and how it relates to Project Overmatch and the introduction of a new threat surface that to be considered, and that things like Hack the Machine and why they're so important for us to go and do proof of vulnerability to determine whether we've got vulnerabilities in our systems and which can be informed by threat intel. Over to you, Jason.
Thanks, Sam. I think we're actually demonstrating the difficulties right now and how to conduct, operations with a whole bunch of people spread out over a huge geographic area. But I'm trying to put up a visual right now to share. I'm not sure it's working because it looks like there's just a Skype bubble on the screen. Sam, can you see an A2AD graphic? All right, it looks like it might have caught up and it's super blurry. So in the interest of not burning up too much more time, I'll just kind of talk about the concepts that, we wanted to cover today. I've spent a lot of time lately looking at things like JADC2, looking at the complexity of not just our own joint operations environment, but what it means to operate with allies and industry partners in some of these environments. And the Navy is an especially interesting problem set when it comes to this because ships themselves are incredibly complex networks. They are also part of larger, more complex networks that rely on both military and civilian infrastructure in order to operate. And so when I see some of these big fancy graphics with all the different weapon systems and nodes and platforms and pipelines and network connectivity, what I see are a whole bunch of endpoints with a lot of different hardware and software operating at different speeds and different locations, relying on a lot of different data streams. And so that to me represents a massive attack surface. And it represents a lot of opportunity for things to be messed with and a lot of opportunities for things to break down. And so the difficulty in this problem set for me comes along with, are we properly anticipating the issues that this system's going to have when it's no longer in a permissive environment? I know that this isn't something that we don't spend any time at all on, but I know a lot of our procurement activities, a lot of our exercises are based purely on troubleshooting this in terms of a help desk type, let's make it work, let's see what it can do, without spending a lot of time thinking about the various wrenches an adversary could throw into a network this complex. And so that's something that, as a threat intel person, I think is the most important part of this problem set, is figuring out how the adversary might leverage our reliance on this technology against us. Is it taking out endpoints? Is it corrupting data streams? Is it all of the above? Is it using information operations to make sure that our folks aren't as confident in these systems as they need to be to get the most out of them in combat? And so that's the angle to this that I think is the most interesting and in a lot of ways the most important.
All right, that sounded, that was fascinating for me to listen to. I'm not sure if Sam and Jason, are you guys still there, or have we covered everything you wanted to talk about today?
I can hear you. I don't know if Sam, I think Sam might have lost audio again.
All right. Well, I have to tell you that the graphic that you showed was actually not unfamiliar to me, and I thought I've never approached it from the viewpoint that you described there in terms of all of the things that we don't think about when we see all those things. You're right. We definitely think about them the point-to-point solution, right? Like just the thing, solve it for the thing right here. So you bring up some really good problem sets that the Navy has to consider, not just the Navy, but the DoD-wide has to consider in approaching those types of big picture solutions that we have to do, right? That's our battlefield. So that's fascinating.
Yeah, thank you. And I've become a fan of those graphics because they are, you could write any number of scenarios about, what if this one point in that stops working, or what if you can no longer trust this data stream as it flows. And so, when you look at the Navy, a fleet is a network, ships are endpoints. They also have they are a network in and of themselves. So what you're taking is a incredibly complex network and a lot of legacy hardware and software, brand new and emerging technology, hardware and software, and sailing it into an enemy environment. And so what are the problems you might encounter? What do we know about the capabilities our adversaries have already demonstrated when you think about the Chinese or the Iranians or the Russians, and how have they sort of demonstrated proof of concept as to how to disrupt these systems in a situation where you need them most? Is it taking down communications? Is it injecting false data? Is it even things like messing with people's personal accounts and social media accounts in order to undermine their confidence in what they're up to, maybe distract them so that all this data becomes overwhelming? There's a lot of different ways to take something that in theory should help you achieve overmatch through a preponderance of data and turn it into something that becomes unmanageable in an adverse or non-permissive environment.
That, for me, that's fascinating. I want to make sure if Sam is back. I'm not sure if he can hear us. All right. Well, one of the things I thought about when you were describing that just now was the idea that, with all the different systems we have and the different types of skills you might need, to actually approach this differently throughout your pipeline, right? Because we're used to doing procurement the way we do it, and we have engineers, we have some really smart people doing work. But to add that in to the conversation, might be a fascinating way to actually think about who we hire, and we bring security in from the beginning throughout the entire process. So we're thinking about all of the things you just talked about. Do you have any thoughts on how we might approach, embedding this in, all of our life cycle, basically, and to make sure that we're thinking about this and solving these types of problems?
Yeah, and I think that's really important because security really needs to be part of any package that you're going to try to field. And so thinking about things like, a good analogy might be to talk about the way the Navy does sea trials. You take a ship out there and you think about what are its sort of optimal and absolute limits in terms of its operative performance, and you push it to those and you see how it handles it. I don't know that we necessarily push our networks and our cyber capabilities the same way to see if they hold up under that kind of stress. We do things like pen testing. We have encryption requirements. We do those things, but to me, those are done from a Blue Force perspective. In terms of, these are the requirements we would like to have for ourselves, but we don't necessarily take that a step further and think about it in terms of a red team or, what happens in a most likely or most dangerous enemy course of action to how we're planning this. And so everything from, as you mentioned, the procurement requirements to how we hire folks to test these things. I think given that we're shifting from a way of doing business that's existed for 20 or more years to a way of doing business that's going to be a little bit different in the sense that we're now going up against near peer adversaries that are far more likely to be either able or willing to break our technology in ways that, in an asymmetric environment might not have been possible. So I think it really comes to putting on that adversary hat and looking at the threat intel and figuring out, how these things can break down based on cyber vulnerabilities, cyber threats, and things of that nature.
So, I won't keep you too long, but I do think that one of the key things about Hack the Machine that is really relevant to what you just said is the idea, like our partners like FireEye and all of the people we have participating, with this event, they bring in an outside perspective on how to solve these problems, right? So we know how to do certain things very well in the Navy, and that we're going to be amazing at doing this too, but we have to get there. And so to get there, we need to bring in all of the smart people who can be our partners to do that. I think that there's possibly, if you think about all of the other industries that the United States protects and, our financial industry and things like that, there's probably a lot of lessons to be learned from the community at large that we can apply to these problems. And I don't know if you have any, key lessons learned that you would have us as a takeaway, so that as we walk out of here, we think, these are things that not only FireEye, but the competitors and these types of events like Hack the Machine can bring back to us in the government.
Yeah, I think you hit on something that's really important there, and that's that the private sector in some ways is better positioned to get into some of these problem sets because, commercial clients are much more concerned with certain types of regulatory requirements and things, and they've got customers that they've got to make sure they keep happy. And that's not to say that the Navy doesn't have the same sort of service orientation in terms of ships have to.
We definitely have customers.
Absolutely, and but it's important to think about the fact that private sector has the time to go do research on some of these things in ways that the Navy might not, because the Navy has much sharper operational requirements. You can't park the whole fleet and do research on things, whereas we can go into a laboratory environment and start picking apart some of these problem sets. We've got people doing ICS and OT research that have been doing it for years, and they're already, there's been recent EOs on things like protecting critical infrastructure. We've seen local public utilities having issues with cyber vulnerabilities and things like that. And so in some ways, they've already been forced to face that reality, and companies like mine have been working on that for them. And so we can bring some of those lessons learned to places like the Navy, because I mean, in some ways, a ship is in and of itself is a power grid in a public utility, because it's got water treatment, it's got power generation, it's got all that stuff afloat, and it's connected to these incredibly complex networks that we're building. And so, if those types of things have been exploited on land, they're not invulnerable from being exploited at sea. And so, for me, again, it becomes a matter of trying to get out ahead of this stuff and think over the horizon in terms of, we know what our adversaries did to us in past wars. So what might that look like in terms of these complex systems in future conflict? So I think it's a really important thing to think about, how we build, just like we're building complex networks, building equally complex, but in a good way, partnerships that can pick apart these problem sets before they, show up in the real world.
Well, I think that you've given us a lot to think about, and I really appreciate your time here today. I know that all the efforts that you're bringing to the table, and I'm glad to have minds like yours at work, and from FireEye are much appreciated, not only by the Navy, but by everybody who's being protected by our Department of Defense. So again, thank you so much for your time. Hopefully we'll catch up with Sam, having a second chance with him. But again, thank you for joining us today.
Absolutely. Thanks for having us. And sorry about the technical difficulties, but like I said, I probably just accidentally did a case study in what happens if you can't find your partner on the battlefield.
And that's a real life challenge. Thank you. All right, so next up, we'll be engaging with Chris Roberts and Nick Foster at GTRI, Georgia Tech. And the Georgia Tech Research Institute develops advanced technology solutions and large-scale system prototypes to address some of the most difficult problems in our national security. As one of the select groups of nonprofit private sector organizations focused on fielding long-term engineering, research, development, and other analytic needs, Chris Roberts from GTRI is here to talk about the impact of UARCs in the Navy. Welcome, Chris. And Nick.
Yes.
Great to meet you. I'm so glad to have you here. So I'm thrilled to hear what you have to tell us from GTRI.
Well, I'm sure it's a great project. GTRI, I'm going to the UARC, and why that makes it such a unique opportunity for a lot of partners. So specifically, we work in the CYPHER lab, which is the Cybersecurity Information Protection Hardware Evaluation and Research Lab, which is a mouthful. But what it tells you is we do a lot of things cyber, not just the enterprise types of cyber security, traditional cyber security types of things, but we also work on building secure systems, secure networks. And my group here, we specifically focus on embedded system cybersecurity. So we're really looking at the hardware that's on a ship, and like in a Grace prototype you guys have here. It would not be uncommon for us to be given one of these modules and say, is this thing safe? Is it defensible against hackers, or how is an insider threat going to cause a problem here? And so this hackathon has been really, really good in that sense, that it's been very, very realistic in the type of work we get to do. So we've had a lot of fun with it. As far as the UARC goes, the UARC, if you're not familiar with it, it's a university-affiliated research center. And what that means is, well, we're a university, which is great. So we get to focus on, more lower-level research. And we never go beyond the prototype level. So we're not really interested in selling 1,000 widgets. We're more interested in working with partners and customers to solve a hard problem and then hand them the solution, which is really, really gratifying for me as a person to work alongside the customer, not as a customer relationship, but as more of a partnership. So I love being able to give them all the data, and there's just no games. So I certainly love that, and being a nonprofit, it certainly has its advantages as well. and then being able to tie it back to the research, the academic side of the house at Georgia Tech is a huge advantage, because we have, we're the #1 school in cybersecurity and privacy right now. So we have a great resource to pull from here at Georgia Tech. And really, like I said, this hackathon's been just fantastic. It's been a struggle at some points because it's very realistic. So even just decoding the NMEA protocol or seeing these logs and not getting much detail about them, that's realistic to how we would do a real project. We get a lot of black boxes in the sense that we have an idea of what they do, but we don't know the language they talk, or the protocols are proprietary. And so a lot of this really is tough reverse engineering and attacking the problem from different angles is very realistic. So we certainly are having a good time here, and I love for my team to be able to get together and attack these problems and really just kind of collaborate together and stretch people in different ways, and they're not been stretched before. A lot of folks get to focus down on one particular, I'm good at solving this problem. Here, the problems, it's so broad that you have to get more well-rounded. And you can see some of the guys in the background here working away on their laptops at the problem now. So I'll ask Nick while he's here. What has been your experience with this?
It's been very exciting. The NMEA protocol, as you were saying, feels like a very realistic attack vector. It's sort of right at the intersection of hardware and software. It's technically a protocol that's implemented like software, but it's very low level. It's not like we're dealing with operating systems and application stacks and that sort of thing. So for us in the embedded systems group here at Cypher, it's kind of like right in our niche. And it's been really fun and enjoyable to dive into all of that.
So it sounds like you guys have a pretty interesting group of people working together on this. Like everyone doesn't have the same discipline, right? And coming into this as they're taking on these challenges?
That's a really good question. So a lot of times I get asked by our different sponsors of, hey, we want to build a group like yours. What kind of careers or what kind of degrees am I looking for? And there's not a right answer. We have electrical engineers, computer scientists. Sometimes you bring in mathematicians. But really, what it comes down to the core is I need really people who are just problem solvers at their at the heart and core of who they are. But those who aren't just they've learned how to learn, and they're not afraid to go out and tackle new things. So I have people who are hardcore computer scientists and they know how to code and do that really well. But now I need to look at an RF problem or look at some hardware, and they have to be able to pick it up. And so the team we have here, the team is just so bright and diverse, and they all have their specialties, but they're all very broad and they can do a lot of other things. So it really gives a lot of strength to the team and to our customers. It gives them a really good kind of a toolbox of talents they can pull from.
We have a lot of team members here who have broad range of talent. They have a little bit of knowledge in a lot of different things, and it allows us to we dive into a new topic and somebody goes, oh, I worked with this a few years back, I know a little bit about it, and they can sort of use that as a starting point to build from there.
Yeah, I mean, for instance, with the Grace Maritime system you have there's a component, an ECDIS, a screen right there. So if you gave us one of those to reverse engineer and find vulnerabilities, we can do that. And then if you bring a different brand of this exact same kind of system, it may be completely different. So you're going to be diving into the whole different kinds of processors, different operating systems, or maybe no operating systems. And so even though the problem may look the same on the outside, it's all going to be different. You need lots of different kind of skill sets to attack it.
I think it's really interesting what you just said, because the Navy definitely has a lot of problems that probably look similar, but they really are unique, and unique problem sets. And I'm sure in your experience, you've got a good familiarity with chaos coming into that. So has Hack the Machine been pretty representative of what it's like really working with the customer and working with the Navy and doing your normal job?
I think it has. It really has. I mean, a lot of what we do, again, is jumping into something you don't know. Nobody here has worked with NMEA 2000 before, and so it's a lot of Google searching and pulling documents and reading technical things, and really just trying to figure out, and then building scripts. And okay, I think it does this, and you run it through the machine and go, nope, that's not right. That doesn't look right. And the experience helps teach you what looks right and what doesn't look right. That's something that really caught me off guard when I first started in this career. I would go to an expert and go, "What do you think about this?" And go, "Well, clearly it's not X, Y, Z." And there's just that experience of what feels right, what looks right. And that's what it's so challenging. And so that's what I love to see, that our team is growing that here. And so we'll be able to take the experience we learned from this hackathon, not just with NMEA 2000, but just the process we go through to reverse engineer these protocols and apply it to our everyday job. So it's really valuable.
Doing something like this, reverse engineering, it's all about expectations. So if you just start running things through a script and you don't know what you're expecting to get on the other side, the data you get means nothing, because you have nothing to compare it to. So it's all about forming an idea of, okay, I think if I do this, it's going to come out on the other side looking like this. And then you run it through, and when it doesn't match your expectation, you go, okay, something about the way I set up this problem is incorrect. One of my assumptions was wrong. And you can sort of work backwards from there and continue tweaking things until you end up putting something in and then getting what you expect out, which shows you that you're on the right track.
So I have to tell you, what's fascinating is that you guys are a good blend of, you have that government kind of feel, right? You understand like the environment of what we're doing here, but you're not for profit. So it's not like you're trying to sell anything. You're just trying to solve problems. And you like the challenge of solving problems. And I think that is something that a UARC, it's a little unique, right? Like that's not everybody in every organization. And so I don't want to keep you all day, but I'm curious, what made you want to be at a UARC, vice going to a company to try, I mean, everyone's trying to solve problems, but to be able to be such a benefit to the federal government, especially to the Department of Defense. What made you want to go that way?
I can go first. I mean, from a personal level, I mean, I started off as a traditional kind of DoD contractor, and it was a fun experience, but you always saw that back end of how can we get more money out of these people? And it was more about making money than it was solving problems and helping the warfighter and making our military more secure. And I really want to help. I want to make my life wants to make a difference. And so coming to tech, it was completely different. That the partnership, the relationship we have with our customers, the level of trust we have, I really value that. And I love that we've gotten to be so trustworthy. They've had problems across the world. They go, we need an expert of this. We need you to go fly across the world to help solve this problem. And it's not a bickering of contracts and money and all that. It's just let's help. Now, we still have to go out and compete for these contracts just like anybody else. That's what's so different about an FFRDC versus a UARC. But it's still really valuable. And so it's nice to know we got such a good community out there that comes to us for help because they trust us. And I personally just love that. What about you, Nick?
The thing that's most exciting about working in this context is there's always new things coming in. I've worked previous jobs where we're developing products, and the product development cycle is very exciting and it's new and you're solving new problems every day. And then at some point you ship that product and you move into more of a support stage where you're just patching things and making small adjustments. Whereas here, we get new problems all the time. It's like as soon as one problem is solved and we found all the issues and sent that information and that report off to the customer, someone else gets to implement all of that, and we move straight to the next thing, and we're in a new, exciting area of research all over again. And that's what's most engaging about this kind of work for me.
So that's awesome. I think one of the things you just said that really, really struck me was the idea that it's exciting for you to come to work every day, right? It's exciting for you to do this and to be part of the team. And it allows everyone who's watching to know that there's multiple ways to be part of this community to help solve these big problems, not only for the Navy, but for the DoD at large. And UARC is one of them. And GTRI is an exemplary example of an organization that's worth being part of. So I'd like to thank you, Chris and Nick, for your time. This was absolutely great. I appreciate your willingness to banter with me and answer my random questions. I hope that this competition continues to be challenging for you, and I can't wait to see how things turn out at the end. So thank you very much for joining us today.
Thank you.
Thank you.
So thank you everybody else for joining us on our community partner session. We're not done yet, so don't go anywhere. At the top of the hour, we'll have a panel from our great partners, Booz Allen Hamilton. Welcome back to Hack the Machine. Now, just like on a Navy ship, we're a live set. So there's going to be some additional noises as the teams are competing over at Grace. Hopefully that won't distract you from the amazing program that we have for you. Now, over the last few years, the Navy has taken proactive steps to adopt and implement data science and artificial intelligence. During this panel, senior leaders will highlight their personal experiences of efforts they've championed. Now, you should know that Booz Allen Hamilton has been a leader in changing how we deal with data, and we have Joe Rohner, Director of Artificial Intelligence with Booz Allen Hamilton, to kick off this panel. Joe, I'm happy to have you here today.
Hey. Good afternoon, Nicole. Thanks for having me. This is so exciting that Hack the Machine is happening right now.
Me too. Well, I will let you take over because I understand you have an exciting panel for us.
Oh, no, thank you so much. And thank you to the Navy for making this happen. This is great. And thank you to my panelists for being here. A quick introduction on myself. My name's Joe Rohner. I'm a Director of Artificial Intelligence with Booz Allen Hamilton. And my primary responsibility within the firm is to help the Navy implement, integrate, and operationalize AI and ML. And I've got some great panelists here today that are going to talk about how the Navy is doing that. Specifically, our topic today is data science and artificial intelligence. How it is serving our Navy. There are many things that are needed to do this successfully, and it's not always just about the algorithm or the technology, but it's ensuring the adoption of this emerging capability. Tactically, the Navy's already creating the tools, training its workforce, and embracing a culture of analytics. I do want to say yesterday when I watched the opening and I got to hear from Rear Admiral Lloyd, Okano, Rothenhouse, and Selby themselves, they all hit on the need for the workforce, for the tools. It was just inspiring to know that, that this is exactly what the Navy needs, and we're already doing it. So with that, let me introduce our panel. First off, we've got Mr. Duncan McCaskill. Duncan is currently the Chief Analytics Officer for the Navy within Don CIO, reporting to the Don CDO, Mr. Tom Sasala. Mr. McCaskill is the program owner for Jupiter, the Don Enterprise Data Environment. Prior to this role, Mr. McCaskill served 21 years in the private sector, providing subject matter expertise to clients across defense and intelligence communities. Welcome, Duncan. Next up, we've got Dr. Bill Lubke. Dr. Bill Lubke is the Director of Logistics and Fleet Support at Naval Information Warfare Command Systems Command, also known as NAVWAR for those of you that don't speak Navy. Dr. Lubke is the executive champion for NAVWAR's AI data science training program, which is empowering its workforce to adopt this capability area. Dr. Lubke has been a member of the Senior Executive Service since 2005, serving in several leadership roles within NAVC. He previously served on active duty, retiring in 2004 with the rank of captain. Thank you, Dr. Lubke, for joining us today.
Totally welcome.
And last but not least, we've got Mr. Bill Farmer. He's the Deputy Program Manager for PEOC4I, PMW 160 Tactical Networks. Mr. Farmer has been a key leader in the rollout of transforming his project management office into an algorithm analytics-driven organization, also known as Algo PMO, which you'll hear about in our conversation. Mr. Farmer retired from the Navy in 1995 and joined the civilian service, where he's held many roles prior to this current position. Our panel is going to fly by today. We're going to try and spend about 10 minutes on each of these topics. And although I may target a question at a specific person, I do encourage the other panelists to jump in if they have a pertinent thought on that. So first off, let's start with tools. And we're going to aim these questions at Duncan. Duncan, let's start off with just the basic question for those that don't know. What is Jupiter?
So I want to start first by saying in the green room, we had some great music that brought me back to my childhood of Kojak and Magnum PI and what have you. But very simply, what is Jupiter? Jupiter is our Department of the Navy, and I'll say Department of the Navy comprising both Marine Corps and Navy. We take a higher view than just Navy alone. It's our enterprise data environment, and it's a technical implementation of our DON data architecture. At a very simple level, Title 44 of the U.S. Code, the Evidence-Based Decision Act or Decision-Making Act, mandated that we have a chief data officer in each executive department in that we start to use data, objective data, for lack of better terminology, to influence decision making. So Jupyter is that enterprise platform for the Don, and it is the first time that I think that that Mr. Sasela and myself have actually been successful in getting an accredited environment fully operational. We did not have any of the lack of management buy-in or lack of funding. We were able to do that because we decided to buy one instead of building one. We signed on as a tenant within the Advana program, which allows us to share data not only internally, but with larger DoD elements.
Thank you. That's great. And as someone who's been serving the Navy for 16 years, focused on analytics, I'm excited by the fact that there's an operational environment out there that is bringing analytics tools to the mission and to our computers, literally, at this point. It's great to be able to access.
I'll still ask Bill for data about every 5 minutes from the logistics and sustainment area, but it doesn't solve the problems of data acquisition, but it makes some things easier.
Yeah. Can you tell me, how does Jupyter contribute to the Navy's efforts to adopt and implement data science and artificial intelligence?
It's I think kind of the simplest way to talk about that is we have kind of a data hierarchy of needs in the department. And so we have all of the homework that we need to do to identify data, clean it, control it, get it in the right place before we can actually exploit it. And what Jupyter does is it provides us a set of, I hate saying best of breed because we're not dealing with canines, but it provides us a best of breed set of tools in which to actually correlate and aggregate data and make it that much more exploitable, not only for data scientists and people across the department who have a high level of data acumen, but also for those who are, consumers of that data and decision makers at echelon. So it really makes that data and makes all of the decisions and all of the things around data and data science that much more accessible to everyone in the department.
That's great, and it's great to have that centralized area. I can imagine the problems or the challenges. Problems is probably too strong of a word with the data acquisition, but I think you're carrying the torch and fighting the good fight to get our data centralized so we can really take advantage of data science and artificial intelligence to empower our sailors and support our missions.
Now, that doesn't mean that it's one data environment to rule them all. We do have our data binned into information domains, and there is a universe of data environments that already exist in the department. So part of what we're trying to do is federate that model and ensure those who are doing good work in the department can continue to do so, but that data is made available at echelon for any decision that needs to get made.
Thank you. Let's get a little tactical. Can you tell me about the types of data or the analytic efforts? I mean, you started to go down that path, but what are you seeing happen in the environment these days?
So there's what we intended, and then there's what has actually happened thus far. So when we started with Jupyter, we envisioned a more of an executive level, enterprise level set of analytics and dashboards and tools to provide that data to an individual who might be an SES, who might be a commander, what have you. What we found is that the demand for the tooling in the platform is at all echelons. So we have elements in the platform now that are at warfare centers, doing great work, elements within, let's say, N81 who are actually doing model testing. I won't get into details of the models that they are testing, but testing things within the platform to test some hypothesis and then going and making it more useful within their domain. What I will say, we have had a lot of demand. Whenever you take data and you aggregate it in one place, people want to start to hang applications off of it. So we're not an application hosting environment. It's more of a decision environment, if you will. So nothing in Jupyter takes the place of any downstream application or for any normal mission and function of the department. Think of it as kind of that out-of-band monitoring, care, and feeding of our activities and in some cases making data that is operational useful for analytics and investigation decision making.
Yeah, I liked how you started your answer on that, and I might dive just a little deeper on that, because you said you had your intended use case versus what's happening today. And I manage a team of data scientists and AI engineers, and there's some intellectual curiosity there. And it sounds like on the Navy side, well, I'll call it liberating data and or democratizing data science or AI. If I heard you correctly, and please correct me if I didn't, are we saying that there are more practitioners out there than were expected, and it's becoming an area where the tools and people are doing their own data science and AI? Is that fair? Is that what I heard?
That is 100% accurate. We did not, I mean, we had kind of an inkling based on just anecdotal evidence of the types of people who were participating in some of the early development and what might you need in a platform and what have you. But we were not expecting to get as crushed with demand as we have been crushed. And there comes the dog. We have not been able to keep up with the demand, not for kind of the data consumption tools, but for the actual, I get my hands dirty in data every day, and I have a key question at my command or at my element that I need to answer. And so I need the tooling to be able to do that. So we are trying to democratize. We are trying to liberate data from the systems that house them within all of the bounds of regulations and law and kind of nebulous, A plus B goes from unclassed to secret, all of that type of stuff. But it really is far more of a becoming far more of a data science environment than it actually is we're just going to provide a dashboard here and there to the senior decision maker.
Personally, I love that it's headed in that direction. And what I'll say for those of you watching that are not part of the Navy mission, we're democratizing data science tools. We're liberating data. Come join the Navy and have fun doing your job and doing really important things. You're hearing it from Duncan himself right now. So if you're watching this going, man, this is how I'd love to spend my days, you're hearing from Duncan right now. We've got the tools and we're making them available. Duncan, one quick last question for you. Looking at the early use cases and whatnot, what's the most exciting thing for you right now about Jupyter before we move on to the next topic?
The loss of sleep about how are we going to be able to meet the demand for all of the tooling in the platform. We started out with that kind of, think big, start small, scale fast, and we have done that, and we are working to scale now. The early use cases were really exercising capabilities within the platform. Can we do this? Can we do that and have it work in kind of an isolated sense before we go to the effort to build the APIs with downstream environments and ingest that data at scale and try to do things in near runtime? So that's the exciting part, is we've proven the concept and we have a lot of interest, especially thanks to some of our senior colleagues at some other senior executive and flag officer conferences last week who are making a pitch. And so now we've got to paddle like ducks under the water to keep up. So it's an exciting time.
Yeah. Well, Duncan, thank you for jumping into the first part of the conversation around tools. I'm going to move over to Dr. Bill Lubke, and let's talk about training. So Dr. Lubke, can you please describe Naval's digital transformation learning continuum for the audience?
Hey, Joe, I would be honored to do that. And before I do that, I wanted to thank you for the opportunity to join the panel today, along with Duncan McCaskill and also Bill Farmer. In listening to the last 10 minutes with Duncan, I can't imagine a system of systems coming together in more harmony. We've got lots of work to do, as Duncan has pointed out, but what we're doing with the digital transformation learning continuum is going to mesh completely into that. And frankly, we need what Duncan is putting together and bringing to us to make the digital transformation learning continuum even more successful. But let me talk about the learning continuum. It's basically three pieces, and they're all related, and they all involve the Warfare Center and the headquarters component of NavWar. You mentioned at the beginning. We're focusing today more on the headquarters workforce, and the three legs of the stool, so to speak, have to do with introductory data science tracks. Secondly, with bringing data science theory to practice, actually using the tools, tool stack, the data that we have, using it to make data informed decisions. And then thirdly, we have what we call select topics in data science, such as a data visualization workshop. Now, I'm going to go back to the first one, and that has to do with foundational knowledge and learning for the headquarters workforce. We've split that into two courses, half-day courses, and we have a course for the employees of the NavWar headquarters, 1,500 or so people. And then we have a second course, which is we also consider foundational for the supervisors at NavWar. We recently made both of those courses mandatory because we feel that data science, data analytics, everything we're talking about today is very fundamental to moving forward. And I'm certainly could have more information on that later. The second piece has to do with bringing theory to practice. The important piece here is we've gone out to the headquarters workforce and we've said, bring us three things. Number one, bring us your data. Number two, bring us a problem to solve. And number three, bring us the right attitude, meaning you're going to jump in and learn to be a practitioner with over-the-shoulder coaching from people that do data science in their regular day jobs, that understand how to apply the various tools and to render the outcomes or the trends that we're looking for to make those informed decisions. And then let's see if we can't render answers there for helping our workforce or helping our command get things done smarter, more efficiently, more cost effectively for the Navy. And as I said a minute ago, the third track has to do with select topics in data science. I hope that answers your question, Joe.
Well, no, it does. And Duncan, it sounds like Dr. Lukey's responsible for all that demand you're getting on your side of the house.
I hope you didn't see me smirking, but Grant Kluzak, who is the NavWar Command Data Officer, and I have multiple sessions each week, and he is driving a significant amount of demand. So I find that all of the NavWar and the NIWC staff, I'm not going to play favorites at all, but you have some very talented people in your command. So thank you for getting them all trained up.
Totally welcome. It's a journey. Go ahead, Joe.
Yeah.
Sorry.
I know you're good. So Dr. Lukey, you talked about the mandatory training, and that's amazing. Of course, I'm a practitioner, so I find that amazing. But can you discuss why it's mandatory or why it's so important to the workforce and why NavWar is lead forward like this?
As many people on this call probably know, NavWar is responsible for communication systems and cybersecurity worldwide across all of the Navy's ships, submarines, and aircraft carriers. We have a tremendous demand signal, a very serious mission to accomplish, and we felt at NavWar headquarters to do this properly, to take us farther into this century, we need to leave behind a lot of the way we used to do our work. We used to conduct business. And by that, I'm talking about simple things such as an Excel spreadsheet and other tools that we used in the 80s and 90s. And we needed to move forward embrace this change, embrace the digitization of literally everything. We see it not only in our working time, but also you can literally do nothing without some type of a digitization or AI or anything else affecting us in our private lives either. So this was so important and so fundamental to transforming our workforce. We said, let's take a half a day for every single employee and a half a day for the supervisors, and let's make it mandatory. We wanted to put and to indicate that actions speak louder than words. We are making these mandatory so that people can begin to build at least the basic foundation of understanding the terms, understanding some of the tools out there, developing a thirst or an interest to go after and learn more about the tools, and ultimately for application of those tools. So let's get the foundation set to begin with and move forward over the next few years to do even more across the workforce, Joe.
Yeah, thank you, Dr. Luby. Yeah, it takes me back to Hack the Machine Brooklyn last year when we did the data science track. We were focused on taking MAF data, maintenance action form data, and we were describing how it's important that everyone understand where data is generated and why it's so important to get it right to get to the end product of analytics at the end. And so I'm just excited that you're taking that same level of consideration, that it's not just about the data scientist, it's about everyone in the data acquisition process, from creating that data point to the system that it's in, to then getting it to a practitioner that can do something with it. And it's inspiring to see the whole workforce be part of this. We are going to move on to the next topic in a minute or two, but can you tell us a little bit about the inspiration for this program? How did this program come to be at NAVWAR?
Joe, back in late 2019, I was talking with the executive director of NAVWAR and some of the other senior leadership at headquarters. And we came upon the realization that at our laboratories, called the NavalX, at our laboratories, those populations of employees had advanced far more than the headquarters workforce had in the area that we're talking about today. And we realized pretty quickly that there would come a time when being able to communicate with them, understand the tools, understand where the tools were taking us with the data-driven decisions, we were going to be speaking different languages. And we said, whoa, let's stop right now and let's put a program into place so that we can bring workforce and beyond personnel, maybe not at the same level as a practitioner level for everybody, but bring us all up so that we can continue to communicate and work collaboratively with our laboratories here using the various tools we've talked about. That was the inspiration to bring it together, and to do that, we realized we couldn't send everybody to college and to get a degree in data science. So we reached out to academia, University of California at San Diego, and we reached out to practitioners, Booz Allen, et cetera, and say, you got the everyday part of this, but we need to bring in some elements of an academic degree to make sure that we can set the fundamentals correctly as they're being taught today. And let's put those two together and then bring to headquarters that next step in having all of NAVWAR, the NAVWAR enterprise worldwide, get onto the same page.
All right, well, Dr. Lukey, thank you so much for talking about the NAVWAR data science training program. Let's move over to our third topic and over to Mr. Bill Farmer. Bill, can you walk us through the concept of standing up an algo PMO, and can you also define algo PMO for us as well?
Yes, certainly, and hope you hear me well. So we're we're a program office, or what in industry may be considered a business unit, right? And so we're responsible for tactical Navy networks, right? Both buying, integrating, testing, and delivering systems to U.S. Navy ships. Given that our program office has a wide scope of activities, and we're a large program too, so we have a lot of people that support the program. So the algorithm-driven PMO, Program Management Office, was specifically initiated to start to orient the workforce, educate the workforce, and get the workforce intimately involved with development of data analytical opportunities that would result in data-driven outcomes for many of the business problems that we encounter on a day-to-day business perspective. So algorithm-driven PMO is one of our strategic initiatives. It's something we're entering the third year of it, because this work is never done. And we're extremely excited about it in our group, which is PMW 160.
Yeah, and Bill, I know that you've been part of the journey since the beginning, and maybe to connect dots for those that don't know Navy lineage, Rear Admiral Rothenhouse was also part of one of the initial stakeholders that talked yesterday in our opening keynote to help make this a reality. And it's great to see that 3 years later, you're still carrying the torch, Bill. That's amazing. Can you share your thoughts on why it's so important for leadership of any organization to set the tone at the top for building this type of culture?
Certainly, thank you. So, leadership setting a tone is definitely one thing, but leadership, really, the way that we exercise it within our program office, right, is really getting the workforce the tools and excited about what this kind of initiative can do for them, right? So it's definitely exciting for us, because we will all benefit so greatly from the things that will be developed as a result of the workforce's effort. So it's culture, establishing the culture. It's giving the workforce the tools, establishing the mechanisms by which everyone will be able to become a data practitioner, right? And take advantage of AI and machine learning and solve our everyday business problems, and things that we need to do to have a successful program office. And it spans across all disciplines, right? So I talked about our mission, right? So we have a budgetary team, we have an engineering team, we have a logistics team, we have test and integration teams, we have people that do documentation, installation. That's a lot of different functions, and they're all integrated and interrelated to some degree, because the measure of our success is delivering a system out to the fleet. So how the workforce, from a bottoms up perspective, can identify opportunities. We have a opportunity tracker. We have an ADG, an algorithm decision guide that we published, provided to the workforce. It gives everyone the top level information they need to be a part of it. And we've done some fun things within the PMW to get the workforce excited. We're tracking about 30 to 40 inputs that we get from the workforce about, hey, this is repetitive work. Is there any way I can do this? Or this information I'm always having to go dig for. Is there any way we can expose this information better, right? So that people have the opportunity to do their work more efficiently. So our role with leadership is to really get people excited about it, and then make sure they have the tools, and then to encourage and reward the participation.
Oh, that's so great. Let's get maybe a little deeper. Can you get tactical and tell us about some of the projects that you guys have taken and some of the success stories there?
Yeah, thank you. And there are many, but I selected 3 to talk about, right? Because it does, represent different areas that we perform in the program office, and it's the activity itself and the outcome. So on the budget and financial side, we've used RPA bots, right, in a way to manage how to pre-populate data that is often repetitive. As you know, as a a government organization, we definitely have structures in place to make sure that we make every dollar count, right? That we're great stewards of the taxpayers' dollars, and that we're auditable, right? Part of that is being able to have the data on demand about where our dollars went. So these bots, what they do is in our accounting system, we have hundreds, if not thousands, of line items of data over at the individual task level of go do these things across all those things I talked about earlier, right? Integration, test, production, all of that, right? A lot of those fields are manual entry fields within our accounting systems today, right? These bots, RPA bots, which are our business financial manager, right, led the team. She's a charter member of the PMO, right, of the Algo PMO strategic initiative. These bots go in and pre-populate the data that before we had people that would just go fat finger, right? So they're able to free up their time to be much more analytical and avoiding rote mechanical tasks. So that would be one example. An interesting thing too is that, as Dr. Lukey said, right, we're take this serious across all of NAVOR, right? And so our PMO, right, which Admiral Rothenhouse was a part of before, we do things, right? Our greatest success comes when we are able to spread that to other program offices. And it'll be an even wonderful ability to spread that across other organizations. So everybody has that common business problem, right? Of manual road information, documentation, right? Processes. So we started it. We've got 3 or 4 other PMWs doing it. They're now also creating RPA bots to do the same type of thing. We use our UiPath licenses, and we've got those out there, and people are actively working it, right, in different program offices and sharing. So that's what's the true excitement behind this. That would be one. A second example would be with we're certainly always extremely involved in ensuring our systems that we deliver are secure. And for anyone that works in the security field, they know that the DISA mandated STIGs, right, which we're all beholden to implement within our systems, are it's a significant amount of work to be on top of. You multiply that by you have management, responsibilities for many systems, right? We have big programs. There are some of our program offices that have lots of programs, but we only have a small amount of big programs. But the big programs put out a lot of different system types. Every one of them has to be validated differently. So we are running probably about 20 to 25 accreditation packages, each of which requires the DISA mandated STIGs to be imposed and evaluated and addressed, right? That's a lot of manual labor today, right? So we've again automated how we can validate the ability of a STIG to be within a given system or not. So we're showing almost a 90% labor return on investment from this validation tool. We've only had it about 6 months now. It's definitely been briefed up to our OpNav resource sponsors and up to ASN RDA, the staff, that we do have this capability. We're starting to share it with externals, but it's a labor-saving device. So those are 2 of the optimized kind of things we've done, right, to drive more efficiency. On the other side, I'll approach it from a different angle, right? Sustainment. we average at any given time about 500 to 700 trouble tickets that we get from fleet units across Navy, right? All the platforms, all the ships, submarines, the shore sites that have our system. We have a very mature help desk, right, that takes on a lot of the responsibility to address those. Some do get tossed to engineering, but they are fighting the fight every day to address those trouble tickets. So what we've done is done a language translation, OCR type, scanning capability where that when we get a trouble ticket, we can auto scan it and immediately go to past corrective actions that have been done, right, to restore something, because people on help desk always change out. People on ships who are asking the questions always change out. So this is a thread of continuity over, when I match keywords to an issue, how do I get the most optimal, best of breed restoral information on demand, right, to help them bring their systems up better. So that's, a slightly different wrinkle than the other two, because that's actually improving, fleet readiness and business operations, and we're very proud of that one. We have others. Sorry if I rambled just a little bit there.
No, it was great. I think this is great and it's wonderful. And we knew this panel was going to go by really quick. So I'm going to put a bow on it at this point. And let me first do that by thanking the panelists. Duncan, Bill, Dr. Lukey, you're all leading various facets that is making AI and data science a reality in the Navy. Thank you for your leadership, and thank you for being with us today. As we were going through this, there were a couple things I wrote down. When we talk about tools, and we're talking about Jupyter, we're bringing best of breed tools. I know, Duncan, you weren't necessarily keen on exactly that language, but we're getting the tools out to the practitioners. We're liberating data, and we're democratizing it for practitioners. For training, we're building the workforce, whether we're talking actually about someone who's developing the algorithm, or maybe the program manager who's developing a system that's going to create that data. And we're making it mandatory at NAVWAR and exploring the idea of doing that in other parts of the Navy. And so it's exciting to see that we're educating the naval workforce on these emerging capabilities. And then in practice, we're seeing that that culture is super important. We have to have tone at the top that says embrace analytic decision making. Don't just keep making the same decision because that's how we've made it. Let the numbers drive you there if that's where we're headed. We're automating business processes so that people can do more fulfilling jobs. I don't want to do the same transaction 10,000 times. I'd like to maybe go focus on something that's more important. And there's real savings, I heard. 90% return on investment. That's crazy. I saw Duncan's eyebrows go up, Bill. He's probably going to be reaching out to you after this panel to learn.
Well, it's amazing to me, Joe, that you have a microcosm here of the entire department. You have a secretariat element, you have a command element, and then a program office, and we are all sailing in the right direction to answer questions with data. And that makes my heart happy. So makes me want to change my name to Bill to be part of the club.
That's great. So with that, again, thank you to the panelists. Thank you to the audience. Thank you to the Navy for putting Hack the Machine on this year. And we'll put a bow on this panel. And thank you, everyone. Have a great day.
Thank you so very much, Joe. I mean, that was an amazing panel. And I have to tell you, after hearing Admiral Nguyen this morning, I have a feeling there's a demand signal that's coming to all three of those gentlemen they're not expecting. So thank you for being with us here at Hack the Machine. And later, we will have Mara Hittner of Matter Hackers, who will talk to us about 3D metal printing, as well as the skills required to enter the advanced manufacturing workforce. See you at 2. Welcome back to Hack the Machine. Now, just like on a ship, we're on a live set, and there's going to be a little extra noise. People are playing the game of grace, so you're going to hear a little extra sound, but hopefully that doesn't interrupt your enjoyment of our next session. Now, I don't know about you, but I bought my 3D printer with all these really big ideas, and what I discovered was that I had a lot to learn about additive manufacturing. So hearing about the ability to print metal really brings home the need to have experts share more details on how this works and the skills required to jump into this as more than a hobby. I'm thrilled to have Mara Hittner of Matter Hackers with us today to talk about this exciting field. Hi, Mara. How are you today? I'm so glad you're here.
It's been a year and I'm on mute.
Well, you know what? That's okay. We all have our mute days. Some of those, that's good, right? So,
well, nice to meet you.
You as well. You as well. I'm so excited about this session because I got to tell you, when I got my 3D printer, I was like, yeah, I'm going to do this, and then I was like, I need to learn some things. So I understand that you're going to give us some really great information on printing with metal and what it really does take to be in additive manufacturing. So I'm excited to hear what you've got to share with us.
Thank you. I'm excited too. I'm here. Is that just on my end?
Oh. No, you might be hearing a little extra noise because we are having Grace is running, and they're actually running games on the machinery. So you're hearing the bridge.
All right. As long as you're good, I'm good.
All right. So awesome. You've got a presentation. I'm excited. I will be quiet. Go.
Oh, okay, great. Okay, so you are seeing the presentation at this point?
Lovely.
Because I'm not sharing my screen yet, so that'd be weird.
Oh, well, we have something here. It says printing composites, flexibles, and metal on desktop 3D printers.
You see that? We just did a rehearsal and it all went well, so you know it's all going to be perfect.
We should have totally recorded the rehearsal. No, I'm kidding. This is fabulous. Live TV, this is what happens.
Okay, so do you see my screen now?
Yes, there we go. Lovely.
Oh, see that? We fixed it.
Success.
Thank you to the tech team. You all are absolute heroes. Well, thank you so much for having me on today. Hi, everybody. Long-time listener, first-time caller, big fan of all of your work. I've been kind of watching, and also best of luck to all of the teams today. You all are doing amazing work. For those of you who are interested in track 3 for the 3D printing, I'm going to talk a little bit about 3D printing metal, but doing that with desktop 3D printers. Because as we've said a number of times during the proceedings over the past day, not everybody has the capability to print on big metal printers, but maybe you have a hobbyist printer at home, or something like a low spot like you have that we've seen on screen from the garden today, maybe an Ultimaker, maybe some 3D printer kits at home, and you still want the experience of printing metal. We do have a fix for that. So I'm going to go through just some materials that are available. I hear we have like 15 minutes, so I'm going to go quick. Spoiler alert, there's going to be a really awesome 7-minute video with a real deep dive on how to print this metal filament. So if that's what you're here to see, I will not disappoint, I promise you. So first of all, you may be wondering who is Matter Hackers, and I will tell you about that. Hold on one second. So I am Mara Hittner. I'm the Vice President of Strategic Partnerships at Matter Hackers. For those of you who are unfamiliar, Matter Hackers is the largest retailer of budget-friendly desktop 3D printers and materials. So people like working with us because we're completely brand agnostic. So if you go to matterhackers.com, you'll see that we carry 70 brands of desktop 3D printers, and everything from the little $300 kits to high-temp machines that can print Peak and Ultim for like under $7,000. We pretty much live in like the under $10,000 range. And then we're also known for our range of filament. We sell over 2,000 different kinds of material, including, spoiler alert, BASF 316L stainless steel, but we'll get to that in a moment. Our clients are pretty much anybody that's designing anything. So prototypes, jigs, fixtures, tools, molds, pre-surgical models for hospitals, replacement parts for the Navy, and more lately, like low to medium volume final projects that are actually going to be for sale. So schools, K-12 to universities, trade schools, they all get their 3D printers from us to train the next generation of additive manufacturing professionals, which of course is very important. And then we also have our makers and our enthusiasts who we really should all be hiring because they have more passion and knowledge for this technology than anybody. So since we only have like 15 minutes together, I invite you to take notes on whatever's going to be useful to you, your business, and then my email is going to be at the end. Email me any questions. I don't think we have a chat or a Q&A here, so please take my email address. I'm here for any questions that you might have. Some best practices for like printing some of these more complex materials that we'll be covering. Matter Hackers creates videos and articles for every filament, so I'd be happy to send you more info via email. So please, please, please be in touch. Okay, let's get into it. Here we go. For those, just quick overview for those who are new to this technology. I would assume everybody's seen a 3D printer or has a 3D printer, but just in case, just review a couple of the benefits and applications and why we're also excited about adopting desktop additive manufacturing right now. So when we're talking about FDM 3D printing, there's a very low cost of entry, like a few $100 to a few $1,000. Very inexpensive materials, which we'll get more into, and zero waste. So you're really only depositing the amount of material that you need to make your part. Another pro for desktop 3D printing is that you can create very complex geometry, as we've seen in the proceedings for this challenge for Hack the Machine. You can use you can use computer design, actually create models that literally couldn't be created by injection molding or any other subtractive methods. So there's a lot of design freedom there. And because of that, 3D printing can be used for hyper customized parts that may just be needed for one application. And then you can rapidly iterate on that design from your desk until you get the prototype or the final part just right. Some of the more common uses for 3D printing, for desktop 3D printing right now, take advantage of that customization capability. So manufacturing aids, like we said, jigs, fixtures, tools, molds, things that help you create your designs no matter how often they change. And that way you don't have to invest in expensive tooling or have the downtime of injection molding for a part when you can just 3D print it in-house. We also see it used more and more for end-use parts, especially for some of the more durable materials that we're going to discuss today. And of course, prototypes for when you need the right tool for the final part is maybe something else, but the ability to rapidly print and test for form and fit and function in-house absolutely makes all the difference. Okay, so let's talk about a few materials that can be used with desktop 3D printers. Let's say the printers that are like under $1,500. Most common, of course, is PLA, which most people are familiar with. Most design and manufacturing clients are starting with this material. It's strong enough. It smells like maple syrup. It's corn-based, so sort of biodegradable eventually for the most part. It's very cheap, under 20 bucks a kilogram, and a kilogram makes a lot of models. ABS is more of an old school material, but it's still used for industrial applications like aerospace, automotive. Legos are made with ABS. It's strong. It can be a bit finicky to print with, and it is oil-based, so this
Oh, I think we are working through some technical difficulties with Mara. What I will say thus far is that I have a little familiarity with the basic 3D printer using the PLA and the ABS. What I haven't used is any of those cooler filaments that are out there. I think that some people are intimidated by the idea of 3D printing, but I think Mara's going to teach us more about how accessible it is for the average person. Oh, we're going to roll to. Oh, okay. Well, we're going to play Mara's video while we wait for her to come back and show you someone who's a lot more better versed than me, a little bit more about 3D printing.
Hey, I'm Dave from MatterHackers, and this is UltraFuse 316L from BASF 3D Printing Solutions. BASF 3D Printing Solutions had MatterHackers test UltraFuse 316LX, their R&D version of the exact same material, UltraFuse 316L. The time is here to explore easy and affordable metal 3D printing. It is now possible to print with real, actual metal on your desktop 3D printer using UltraFuse 316LX from BASF 3D Printing Solutions. .3D printing has been around for a few decades now and is well established, but generally limited to thermoplastics. Similarly, metal injection molding is now a commonplace as a manufacturing process. You most certainly have used tools or devices that have metal injection molded components in them. Now, 3D printing and metal injection molding are joining forces to introduce metal 3D printing to the desktop market in UltraFuse 316LX. UltraFuse 316LX is a metal polymer composite filament developed by BASF 3D Printing Solutions team to produce metal components in actual stainless steel type 316L using standard 3D printing processes and subsequently an industry standard debinding and sintering process. This material was created specifically to make it easier, faster, and more affordable for any businesses or engineers using traditional manufacturing methods like CNC milling or even metal injection molding. Maybe you already have a desktop 3D printer and are looking for more strength and durability from real metal parts compared to the plastic you may be using today. That's where we fit in. We've succeeded many times over with printing, iterating, and designing parts that then got sent out for debinding and sintering, and we've received back beautiful, durable metal components. I want to take a moment to guide you through the most important considerations when looking to succeed with this material. And the first is designing for additive. You'll be 3D printing these parts, so you want to make sure you're designing for that manufacturing method. And 3D printing is absolutely a manufacturing method that has its own considerations. So if you're CNCing a part or metal injection molding a part today, you'll want to make sure the design considerations for 3D printing still apply to those parts. Next, the part should be flat on one side. The printing process itself relies on the material's adhesion to the bed surface. This ensures there's no warping, especially while the part is cooling on the bed. You also have to design with a high width to height aspect ratio. When designing parts for sintering, it's good to consider the strength of the part at its weakest state, a brown part, after debinding. At this stage, the more stable you can make the design, the more likely the part is to go through the sintering process intact. For this reason, designs that are wider than they are tall, think pancake instead of tower, are often more successful. This isn't to say you cannot succeed with those type of designs, but it takes some experience and consideration. It's also important to design features to be generally homogeneous. This is a fancy way of saying don't have drastic variations in your part thickness. Similarly, avoid thin walls. Thin walls can delaminate during the sintering process, so be sure you use a minimum wall thickness of 1.5 millimeters. That's a good place to start. Another thing to avoid are overhangs. For best results, overhangs should be 50 degrees or steeper. This prevents the material from sagging during the sintering process. Lastly, keep parts within a 100 millimeter cubed build volume. Now that you have your parts designed and you're preparing the model for 3D printing, it's important to note that these parts will shrink anisotropically. For that reason, you'll want to scale your model to be sure that the part you receive back is to the dimensions you're expecting. And here's the proper scaling to make sure that's successful. In order to print with UltraFuse 316LX filament, your 3D printer will need to be equipped with the proper components. For instance, a heated bed capable of at least 100 degrees Celsius, a glass bed with Kapton tape or Dymafix bed adhesive, and a hardened steel nozzle. Now that we know your hardware is capable of printing this material, let's talk about the print settings themselves. Set your heated bed temperature to between 100 and 120 degrees Celsius. The hot end temperature should be 230 to 250 degrees Celsius, but not to exceed that 250. Go ahead and turn your part layer cooling fan off, because this could actually induce warping during the printing process. We recommend a layer height of as small as possible, even starting at 0.1 to ensure better part quality and, more importantly, higher density of the material. Print speeds of 15 to 40 millimeters per second are a great place to start. You can certainly go faster with that, but low and slow is always the best place to begin. And lastly, infill. Set it to 100%. When you start your 3D print, it's critically important that your first layer is perfect and your extruder is calibrated. Any errors in the first layer could propagate and result in poor part quality. Any gaps or voids on account of your extruder not being calibrated could lead to failures during the debinding and sintering process. The part you remove from your 3D printer is called a green part. In this state, it's very easy to clean up and is relatively soft. Remove any brims, clean up any printing artifacts that may have been left from the printing process. A razor blade, deburr tool, or even a small file set are recommended for this cleanup. It's much easier to clean up these parts in their green state than when returned as sintered metal parts. If any warping occurred during the 3D printing process, now is a good time to sand that surface flat. Lapping the bottom surface will have the part processed through the debinding and sintering steps with greater feature and dimensional stability. It's important now to remove any contaminants, oils, fingerprints, bed adhesives, because the contaminants can cause failures during the debinding and sintering processes. Now you have your printed green parts ready for debinding and sintering. BASF 3D printing solutions, with the help of their distribution partners, have made it really fast and really easy for this stage of the process. They're setting up a network of debinding and sintering services. So you package up your parts, send them out, and very quickly they come back fully debound, sintered metal parts. You now have your parts back from sintering, and these are full metal stainless steel 316L parts. You can process them any method that you'd like. You could grind for material removal, polish in any method you see fit, or even CNC machine these for higher tolerance features. If you, your business, or manufacturing process are looking to rapidly create prototype or production metal parts without the setup costs and time of traditional manufacturing methods, then UltraFuse 316LX is for you. Using this material on a standard desktop 3D printer is a cost-effective alternative to typical subtractive methods or setup and tooling costs for metal injection molding. To learn more about UltraFuse 316LX, go to BASF's 3D Printing Solutions website or visit matterhackers.com for more in-depth guides on how to succeed with this material.
Well, I have to tell you, that was fascinating, and I found myself captivated watching the video. But Mara, I'm so glad you're back. I was so engaged with what you were presenting, and then you disappeared. So I'm thrilled that you're back. I learned a lot about how to print with metal, but I don't know if I have all the skills I need to actually do 3D printing in general. So can we talk to you a little bit more about that? Okay. I think we lost her again. That's all right. Today has been enlightening with the video that we just saw, and if we get a chance to back with Mara, we will, but I will tell you that you should take a chance. Reach out, learn about 3D printing at home, and about the additive manufacturing workforce, because it's needed by the Navy, it's needed by the Department of Defense, and frankly, it looked like a lot of fun. So this has been Hack the Machine's session on 3D printing and additive manufacturing. We hope that you come back and join us tomorrow at 11 a.m. Eastern, where we will be learning more about how we're doing on those challenges and the different tracks. And hopefully, hearing from more of our friends and partners here at Hack the Machine. All right, so see you tomorrow.